Hello there. Thank you for clicking on the practice set for absolute value inequalities. Please like and subscribe for more math content. Drop a comment below to let me know what you think, and check out the many other videos that we have on the channel. So as always, pause the video to work these problems on your own and then come back to check your work. Okay, so for these ones, we are going to be doing them out by hand. So let's start with number one. And we want to be thinking in our heads that distance from zero. Okay, so the distance from zero is greater than or equal to, not memorizing a pattern. Now, in the lesson, I wrote out the like x minus 4 or something like this. X minus 4 has a distance from 0 greater than or equal to 6, and actually wrote it out in words. That would not be expected, but that is what should go through your head. Now, sketching it is going to be a big help for most students at the outset. So if you're looking for a distance greater than 6, those would be these points out here, okay? That's further away from 0 than 6, and it's or equal to 6. So we're going to include the 2 points that have a distance equal to 6, and it's x minus 4 that has that distance. So x minus 4 is either less than or equal to -6, or x minus 4 is greater than or equal to 6. In both of these, we need to add 4. So this first one would be x is less than or equal to -2. In this one, x is greater than or equal to 10. And if you were doing this out now, what you guys probably didn't see it because, or you didn't hear it because I re-recorded it, but had like this moment of did I do this right in the lesson? But I think I did. In this case, what you can't do is go back to this and use this number line because you'll notice that you have other intervals on here. So less than or equal to -2, you've got that negative infinity going up to the -2, including, and then use the union, and then greater than or equal to 10 would be 10 to infinity would be your interval notation. The second one, we've got the absolute value of 3x is greater than 5. So again, kind of looking at it, here's the 0, here's the 5 and the -5, and we want a distance from 0 that is greater than 5. So that's going to mean we have to walk all the way to the 5 and then past the 5, but not 5 itself, because now it's not equal to 5. And same in the other direction. And what's over there? That's the 3x. So 3x is less than -5, or 3x is greater than 5. And it can't be both of those things. Like it can't be less than 5 and also greater than 5. So we don't want to use and there. Sometimes students use and to indicate it's this set and also this set is the solution set. But the word you want there is or, because we're not talking about what the set is, we're talking about what x is. Now to solve these, we would simply divide by 3. So x is less than -5/3, or x is greater than +5/3. And if you were doing interval notation, this would be negative infinity up to -5/3. Use the bracket because it's not included, or 5/3 to infinity. And if you just pause for a second, that's not an overwhelming amount of work. So when you look at how much I've written out, that's like the maximum, and I'm actually giving the answer in 2 different notations. So it's not a ton of work. Sometimes I think these problems feel like a ton of work, but they're not. All right, so moving on. So now we have more interesting ones where we have more interesting expressions. So we have another greater than, so the distance from 0 is greater than 4. And so that means when we're like walking away from 0, we need to go past the 4. So 2x plus 1 would be way over here on the right, to the right of the 4, or to the left of the -4. So 2x plus 1 is less than -4, or 2x plus 1 is greater than 4. We're going to subtract 1 from both sides, so that'll give us 2x is less than negative 5, and then we'll divide by 2, so x is less than 5 halves. Or over here, we'll end up with 2x is greater than 3, and x is greater than 3 halves. That looks like a 3. We'll clean that up. In your interval notation, this would be negative infinity up to negative 5 halves, unioned with 3 halves to infinity. Finally, a less than. All right, so number 4. So we have 2 times the absolute value of x minus 5 is less than or equal to 6. So this is the first one where we need to do something to it. And if you need to, you want to go watch the video on absolute value equations, which should be linked somewhere. I got to remember to link. I got to link a whole lot of videos in the description box. Absolute value equations. That's for the practice set. Okay, so we know we don't want to distribute the 2. In this case, it would actually come out okay, but if you had a negative, it would not be okay. And we don't want to get in the habit of doing stuff that only works some of the time. So we're going to get rid of that multiplication by dividing, and that's going to leave us with the absolute value of x minus 5 is less than or equal to 3. So that's our distance from 0. And the distance from 0 is less than or equal to 3. So if you're walking, starting at the 0, all of this would be less than the 3, and we can go all the way out to the 3. The 3 is included. And there we go. There's our distance. So what's in there? That is x minus 5. So negative 3 is less than or equal to x minus 5 is less than or equal to 3. And when we go to solve this, we want to add the 5 everywhere to make sure everything stays balanced. So this would be 2 is less than or equal to x is less than or equal to 8. In interval notation, this would be the interval from 2 to 8. Alrighty. Last one. So this one is going to be a little bit tricky. We just got a little bit more going on. I need to get my absolute value isolated, okay? Because that other stuff complicates the distance from 0. Like I don't want to have like a negative 2 multiplied in there and think about that. So when we go to solve this, we're going to start by subtracting 4 from both sides. Could you start by dividing both sides by negative 2? Yeah, but that is not going to be a friendly way to start. 4 minus 4 is 0. 2 minus 4 is negative 2. Now we're going to divide, and this is one of those things when you divide by a negative, you've got to flip the inequality around. So check out my video on solving inequalities, okay, if you want to see an explanation or illustration for why that is. All right, so we flip the inequalities. So now we're dealing with another greater than. So the distance from 0 is greater than 1. So there's my distance of 1. We want a distance greater than 1, which is going to be all of those and all of those. So we have x plus 3 is less than negative 1, or x plus 3 is greater than 1. Go ahead and subtract 3. So x is less than negative 4, or x is greater than negative 2. If you were doing this in interval notation, it would be negative infinity. Looks mostly like an infinity. Unioned with, so negative 4, union with negative 2 to infinity. All right, so those are the last of the ones that we were to do by hand. The remainder of these are done on Desmos. And so we want to get some practice with that. So we have problem 6 and problem 7 here that are Desmos ones. There's number 6, so you should have typed it in. And if you recall from the lesson, we're looking at the number line there. Okay, the dashed lines indicate an open circle, and the shading indicates where the solution is going to be. That's where X is going to be. And so there, it looks like we have -7 is less than X is less than 1, or -7 to 1. And you don't have to do any of the algebra. Like for it, you can just like put it in there, and the trick is reading it off of the graph. Okay, here's the second one, and I think that's all copied in there. So this ends up being another less than 1, because when you go to solve it, it flips the inequality, and it looks like we've got solid dots. The solid line means we're going to have a closed circle, and it's in between, and that looks like -5 is less than or equal to X is less than or equal to 1, and would be -5 to 1. And so you can do this with less thans or greater thans. Let's see what we got next. Have a greater than, yay. All right. Okay, so here's one that's a greater than, and you can see it's just typed in there. Solid line means it's a closed circle, and we're dealing with the distance is greater than in this one. So we would have here X is less than or equal to, what are we counting by there? Ones. So that would be -12, or X is greater than or equal to 0. If you were doing this with interval notation, there's your -infinity and positive infinity. So -infinity to -12 unioned with 0 to infinity. Much faster to do it that way. But again, like it's good to understand the concept behind it. That is why we study stuff. All right. Now for 9 and 10, these ones are more like, okay, what do you get when you graph this and why? Now, we want to go back to the definition here. The distance from 0 of X minus 4 is less than -2. Well, can a distance be less than -2? Go back to the analogy of your like fitness watch that tracks your steps. It essentially tracks your distance, okay? Like how many steps you're taking. There's no like negative. If you're not moving, you can have a 0, but that number only goes up. There's only positive distance. It doesn't matter what direction you're going in. There's no way for you to get a -2. And so when you graph it, you get nothing. Now, what that essentially means is that X is like, well, the solution is the empty set. So there's nothing in there. And your reason goes back to the definition. Distance cannot be negative. Okay, like now there are things like displacement, which gets into like a vector thing that can be negative. It indicates direction, but distance can't be negative. Your fitness watch does not subtract steps. Okay, so that one you should have ended up with the empty graph, and you want to think, okay, well, why did that happen? You got to go back to the definition. Next one says the distance from 0 is greater than or equal to -1. Well, if you picture a number line, okay, here's the -1, here's the 0. The smallest distance can be is 0, and then it's positive. Okay, so take a look at like here's where the -1 is. Will the distance be greater than or equal to -1? Yeah. Now it'll never be equal to the -1, and it's not ever going to be anything in here, but every single point like in that set meets the qualification of being greater than -1. So if you have like the number 1, well, 1 is greater than -1. 2 is greater than -1. 3 is greater than -1. 0 is greater than -1. All of these points are greater than -1, which means this statement is always true. Like it doesn't matter what you put in there for X, when you go to take the absolute value, you're going to get something greater than -1. So when you graph it, you get everything. everything. So just to reason it out, let's say you take x is equal to negative 10. So if you plug in x is equal to negative 10, negative 10 plus 2 is negative 8. The absolute value of negative 8 is 8, and negative 8 is indeed greater than or equal to negative 1. That's true, so 10 works. 0, plug in a 0. 0 plus 2 is greater than, or absolute value 0 plus 2 is 2. Absolute value of 2 is 2, and 2 is greater than negative 1, so 0 works. You can come over here and do a 10, okay? 10 plus 2, that's 12, okay? It doesn't matter what you put in there for x. As soon as you take the absolute value of it, you're going to get something greater than or equal to negative 1. So all of the numbers, so you could say that this is all real numbers. You could say it's everything from negative infinity to infinity, and the reason for that is all distances are greater than negative 1, okay? And the equal to might like throw you off, but there's nothing that's equal to. Well, there doesn't have to be. Like every value for x is going to meet, it just has to meet one or the other, greater than or equal to. So like they all meet the greater than. So two kind of interesting situations asking you to like interpret the graph and then reason it going back to that definition. All right, so that's that. Please don't forget to like and subscribe for more math content. Drop a comment or question or request below, and check out the other videos available on the channel. I hope to see you in another video soon.